everyone. Today we are going to continue Chapter 1 Numbers. The objectives of today's topic are: you will learn the conversion of numbers from one base to another. Today you will learn conversion of decimal to binary, decimal to octal, decimal to hexadecimal, as well as binary to decimal number. In each type of conversion, you will learn to convert two types of further conversions. First, an integer number conversion. Two, a fractional number conversion. You all know what is an integer. A number having a positive, negative or a zero value. That is 12. And a fractional number. A number with the decimal point. First, we are going to learn conversion from decimal to binary number. Two types of conversions will be there: integer value conversion and fractional value conversion. Students, open your book at page number 16. First topic, conversion from decimal to binary. Integer value conversion. To convert an integer decimal number to binary, divide the decimal number continuously by 2. The corresponding binary number can be obtained by tracing the remainders in reverse order. Let's understand with the help of an example. Here, I am going to convert 19, that is a decimal number, to a number with the base 2. That will be a binary number. So, we are going to divide this number by 2. 2 9s are 18 and the remainder is 1. 2 4s are 8 and the remainder is 1. 2 2s are 4 and the remainder is 0. 2 1s are 2 and the remainder is 0. We are going to carry out this process of finding the remainder until the quotient becomes 0. So, when the quotient becomes 0, the remainder will be 1. So, when the quotient is 1, we divide it to, then this 0 is quotient and the 1 is remainder. Now, we will write the remainders in the reverse order: 1, 0, 0, 1, 1. In this way, we convert this decimal number into binary number. Next topic is fractional value conversion. Here a number 30.25 is a decimal number as the base is 10 and we are going to convert it in the binary number. The base is 2. This number has two parts. 30, that is an integer part. 0.25 is a fractional part. So, we had already learned how to convert an integer part to the binary number by dividing the number by 2 and writing the remainders in the reverse order. So, we had converted 30 to binary number, that is 11110 base 2. Now we are going to learn how to convert the fractional part of the number, that is 0.25, to the binary number. So here we are going to multiply the fractional part with 2. The answer is 0.5. Here 5 is a fractional part and 0 is an integer. We have to write integer on a side. So I have written 0. Next again we are going to multiply the next fractional part, that is 0.5, with 2. The answer is 10. So 1 is an integer and 0.0 is a fractional part. So in this process we have to multiply the fractional part of a number by 2 till the fractional part becomes 0.0. So here the integer comes 0 and 1. So this fractional part 0.25 base 10 is converted to binary number base 2 and the answer is 0.01 with the base 2. Now on combining 1 and 2, we will get 11110, that is of 30, 0.01, that is of 0.25 with the base 2. So final answer is the number 30.25 is a decimal number with an equivalent binary number, that is 11110.01. Students, open the book at page 17. So, conversion of fractional part is done by continuous multiplication of the fractional part by 2. In this process, the integer generated is taken aside and the rest of the fractional part is multiplied by 2. The process stops when the fractional part result is 0 or become recursive. Hence, students, you have noticed that for integer conversion part, the remainders are taken in reverse order. And for the fractional part, the quotients are taken in forward order. Now we will learn second conversion, that is conversion from decimal to octal. Again, it is further divided into integer value conversion and fractional value conversion. Students, you have noticed that in binary number, the base is 2. So, we had divided the number with 2. And in fractional value, we have multiplied the number with 2. So, now we are going to do decimal to octal. So, octal number, it has the base 8. So, in integer value conversion, we are going to divide the number by 8. And in fractional value conversion, we are going to multiply the number with 8. Students, open page number 19. Integer value conversion of decimal to octal. To convert an integer decimal number to octal, divide the decimal number continuously by 8 till it becomes 0. The corresponding octal number can be obtained by tracing the remainders in reverse order. Let's do with the help of an example. Here I am going to convert this decimal number to octal number. We are having a number 125. 8 divided by 125 divided by 8. So the quotient is 15 and the remainder is 5. 15 8s are 120. So we get the remainder 5. 8 1s are 8 and 15 minus 8 is 7. So in this way we have got the numbers that are remainders 175. As you all know, we are going to write these remainders in the reverse order. So the answer will be 1758. Hence we have converted decimal number into the octal number. Next is fractional value conversion. 90.25 base 10, that is decimal number, to an octal number. Here 90 is an integer part, 0.25 is a fractional part. You all had done how to convert this integer part to an octal number by dividing it by 8 and writing the remainders in reverse order. So answer is 132. Now how to convert this fractional part? As I told you earlier, for converting decimal to binary, we have multiplied with 2. But now we are converting decimal to octal. So we will be multiplying by 8. 0.25 into 8 is equals to 2.00. So here the fraction becomes 0 and integer is 2. We will write integer 2 over here. As the fraction becomes 0, so we will not multiply it again with 8. So 0.25 base 10 is a decimal number with an equivalent octal number is 0.2. Now we will combine this integer value conversion and this fractional value conversion. So answer is 132.2 base 8. Hence we had converted this decimal number into octal number. Students, next is conversion from decimal to hexadecimal. Again, it is further divided into integer value conversion and fractional value conversion. Now, the hexadecimal has the base of 16. So, we are going to divide the number by 16. And while doing the fractional value conversion, we are going to multiply the number with 16. So, let's do it with the help of an example. Integer value conversion. Students, as you know that in hexadecimal number, we are having 0 to 9 and A till F. So, if a remainder become more than 9, then it will be given an alphabetical value. So, when we convert this decimal number into a hexadecimal number, we are going to divide it by 16. So, 16 fours are 64, the remainder is 12. As we are not having 12 in hexadecimal number, so its corresponding value is C. And thus we had calculated the remainders. So the answer is 4C. As we have to write the remainders in the reverse order. 76 with the base 10 is equals to 4C with the base 16. Now we will do fractional value conversion. Here 100 is an integer part and you all know how to convert this decimal number into a hexadecimal number. For the fractional part 0.25, we are going to multiply this with 16. The answer is 4.00. As we have got the fractional value 0, so we will not continue the multiplication. Hence, we will combine both the steps of integer part as well as the fraction part. The answer is 64.4. Hence, we had converted a decimal number into a hexadecimal number. Now, students, we will learn how to convert a binary number to a decimal number, like 101 with base 2 to a number with the base 10. As you all are seeing that we are going from a lower base to a bigger base, so we are going to do multiplication. So students, to convert binary to decimal number, multiply the digits of the binary number by 2 raised to power n, where n begins with 0 for the digit in units place and increase by 1 each time for the next digit with the higher place value. And finally, we are going to add all these products. Let's understand with the help of an example. 101. This is the unit place. We are going to multiply by 2 raised to power n and n begins with 0. So 1 multiplied 2 raised to power 0. Anything raised to power 0 is 1. So 1 ones are 1. Next 0 multiplied 2 raised to power 1. Anything multiplied by 0 is 0. 1 multiplied 2 raised to power 2, 4. So at the end we are going to add these all. 4 plus 1 is 5. So 5 is an equivalent decimal number for the binary number 1, 1. Students, come to page 23. We will learn the fractional value conversion. To convert the fractional part of a binary number to decimal, multiply the digits that appeared after the decimal by 2 raised to power p, where p begins with -1 and goes on decreasing by 1. Let's do with the help of an example. 101.11. I'm going to convert this binary number into a decimal number. So we had already learned how to convert integer part into a decimal number. That is step 1. Now we will learn step 2. The fractional part is 0.11. I will start multiplying with 2 raised to power minus 1, 2 raised to power minus 2 and so on. But you have to start from this point, that is after decimal. So 1 into 2 raised to power minus 1 is 0.5 and 1 into 2 raised to power minus 2 is 0.25. Then we are going to add these two numbers. The answer is 0.75. That is the step 2. Now we will add both the answers obtained in step 1 and step 2. 5 plus 0.75. Answer is 5.75. So decimal equivalent of binary number 101.11 is 5.75. In this way, you can convert binary number to decimal number. So students, today you had learned the different type of conversions of numbers from one base to another. There are many more conversions and we will be continuing our another topic in the next class. Do practice the related sums. Thank you.